Hello friends, good morning. In this video we will see about the prototype design pattern. Okay, so let's start with it. What is a prototype design pattern? So it is a type of creational design pattern, as we all know. So creational design pattern means to deal with the creation of the objects, how objects are get created in the memory, and various type of, you can say, how to deal with creation of the object. Okay, so prototype design pattern is a type of creational design pattern, and we all have used this pattern in our day-to-day life coding scenarios, because as we know that clonable is a part of our JDK library, and clonable interface is very useful to make a clone of the objects. Okay, so we all have used this prototype design pattern, but just we need to know more about the theory part and at the its actual implementation of the prototype pattern. So we will definitely see the code base at the end of the video, and it is very simple and easy to understand and implement. Okay, so let's move ahead. So first of all, what is a prototype? So prototype means blueprint or idea to build something. If we want to build anything, any type, any machine, any device, let's take an example of sport car. Okay, so if we came to know that something has already something is already there, like what we want to build. Here we have taken example of sport car. So we know that already there are many models, many cars available, which we know as a sport car. So what we do, we will take some idea from it. Okay, we are not going to design sketch, or you can say build everything from a scratch. Okay, we are not going to design from a zero level. We will definitely use the material what we have already available in the market. For a car we will use sketch, some design, some color combination to build our own car. Okay, so same thing applies in object oriented programming. So prototype design pattern is about to construct or build a new object from the existing one. It is very useful when we have a object, or we can say to build our object, to build anything we need to it is very costly, or may have latencies to create an object. Suppose our object is taking data from, you can say, multiple APIs. We are using multiple different third-party APIs, and from that we are constructing a new object. Okay, so we want to create 10 objects of same type. So every time we are hitting the third-party APIs, getting data and building object 10 objects, so it is not worthful. It is a waste of time. Okay, instead of that, construct one object by getting data from that APIs and create clone of that object, so we can easily reduce the time and latency of creating a multiple object of the same time. Okay, so in single line you can remember it as a creating a new object from the existing one. So JDK from our Java library, there is a java.lang.clonable interface is there to support, or you can say it's an example of prototype design pattern, or to support a prototype design pattern. Okay, with the help of this interface we can create a clone of our existing object. We have base object and we want to create a new different objects from the base object, so we can use clonable interface to create the clones of our object. Okay, so what are the advantages of the prototype pattern? So every pattern has some capabilities to solve a real time issues or real life challenging problems. So it reduces the initialization overhead. Initialization overhead in the sense object initialization overhead. So always copying one thing is more better than creating a new thing from the scratch, because it will take more time, more efforts to create a new object in creating a new object instead of cloning the existing one. Okay, so it will improve the performance. Second thing is improve performance. Obviously if we go to create a new object, then it will take more time. Okay, so object cloning is faster than creating a new instances, especially when dealing with the complex and heavy objects. It enhances the customization. We have one base object and we want to create multiple different cloning from it. So whatever clone we have created, we can customize that clones based on our requirement. Okay, so we have base car and we want to create a multiple different cars, sport car, SUV car, so we can customize their seat capabilities, their colors, their speed, their engine capabilities. Okay, so enhance customization, you can say. It maintains the encapsulation. While using prototype pattern, we are keeping mind we always, you can say, concern about the encapsulation. It means we are not going to expose our object formation or object cloning logic to the client. Okay, whenever we use clonable interface, what we are doing, we are implement that clonable interface to our Pojo, and we override that clone method and provide our customization or our implementation to clone the, or you can say to clone the or copy our variables, our objects of the of our Pojo class. Okay, so maintain encapsulation in the same class. Okay, prototype encapsulates the object creation and initialization process with the class itself, preserving encapsulation principles. Client do not need to access the internal of the prototype object to create a new instances. Okay, hope you understood. Let's move ahead. So let's see the basic implementation of the prototype design pattern. Here we are going to take an example of car Pojo. We will use obviously clonable interface and one driver class to demonstrate our code. Okay, our flow. So let's move ahead. Here we have car Pojo. I have used Lombok notation to shorten the code, means to provide getter, setter and all argument constructor. Okay, so you can see I have implemented clonable interface here. Okay, and provide the implementation for the clone method. Okay, so keep in mind that clone method always performs a shallow copy of the object by default. So in case your Pojo contains some mutable object, you need to compulsory perform a deep copy for that mutable object. Otherwise what will happen, if you perform a clone of the base object and modify anything, modify that mutable object, it will also impact your base object. So it is not a good practice. So you should always perform a deep copy for the mutable object. Suppose car has engine. Okay, and engine is a separate class. It has some number of variables, methods. Okay, so you need to define, you need to perform a deep copy for that engine object inside the clone method. Okay, let's move ahead. So here is a driver class to demonstrate the flow. Okay, so we have created base object with the help of the class car. So we have created first our base class. It's a base model. Here is 2022. Okay, we have, then after we have created a sport model. In that we have customized some properties like year and model. We have defined that sport model. Okay, then after we have created SUV car model from the base car itself. Okay, you can see. So we have defined some separate some different properties to our base class to create a new clone of new clones. Okay, and in last we are printing all the properties from the three objects, right? So car is our base object. With the help of first object we have created, which is a base car, we are creating two more clones of that base car, sport model and SUV car. Okay, and we have defined different set of attributes like year and price and model. okay, to customize our newly created object. Okay, so let's see the output. So base car is Toyota base model, and your so sport car, SUV car has different properties, you can say. You can see in the console. Okay, so this is how the prototype design pattern works. uh, Hope you understood. Let's see an example. What if you have mutable object like array list or user defined objects in your class? As I have earlier mentioned that you need to provide a dip copy for them. So here I have a class which name is mutable object. So I have overridden clone method, and in that method I have provided dip copy for the array list. Means I am creating a new array list, and inside that what I am doing, I am passing the list object. Okay, so whenever we changing any thing to our newly created or our cloned object, it will not impact to the existing one, or it will not impact to the our base object. So this ensure that changes made to the list in one object do not affect the list in the other object, including the base object. Obviously it should not get affected our base object, because we are copying from the base, we should not get altered the base object. Okay, it is about how to handle mutable failed objects while using the clone method. Okay, I hope you understood this as well. Okay, yeah, so this is all about how to use prototype pattern in our coding scenarios. Okay, and how it is helpful. So you can assume, you can remember it as a to creating a copy, or to creating a complex or a heavy object. Okay, we are using prototype pattern. Okay, yeah, so thank you guys, keep me subscribed for more videos. Have a good day.